To show you how to set up a chart in Excel, and we're going to use our data here from our determination of absolute zero, and we've got the temperatures down here. They'll be in the A column, those will be the x-axis. These are the volumes, and those will be from the on the y-axis. Now of course you'll be getting these from the data sheet. This is all the information you would have filled out after you did the lab, and all these will have all these volumes here, and these will be the corresponding temperatures at each part. So the temperatures here will make up your x-axis and the volumes will make up the y-axis. So once you've got all that data there, and you'll obviously have a lot more than I have here, what you'll do is you will select all the data. You do that by just dragging it across here, and then you can insert, and you want to insert a scatter graph. So this is going to change depending upon what kind of version of Excel you're using as well. This is the version I have, so this is why I'm making the video using it. You may have to go onto Google and look at how to do some of these different things that I'm showing you how to do here. So there's your chart. I'm going to enlarge it a little bit. There we are. I can change the title just by clicking on it, and I'm going to put in determination of absolute zero, and I'm going to put my name here as well. And I want you to do the same thing when you put together your chart. And we also want to do the axes. We want to label those. We do that by clicking on this over here, which is add chart element, and we can click on the, let's try that again, the axis titles. There we go. So that's going to be a volume, sorry, temperature. It's going to be on the x-axis, temperature. And that's going to be degrees Celsius. We always title these with our title and the unit. Do the same thing on the y-axis, so axis titles here, and we're doing primary vertical. There it is. And we can do the same thing with that. So I'm just going to go ahead and erase that and put in volume. And that's in milliliters. So you will notice that we do have some points here as well, which is good. So we've got our graph set up now. Now we need to double click on the, actually we're going to right click on, we're going to double click on one of the points here, and you'll see that what happens is that they become these selected points. Now we can right click on that, and we can click on add trend line. So this doesn't change, I don't think, for any version of Excel. So we've got trend line, and we want to display the equation on the chart, and this will allow us to get our slope and our y-intercept. Now the y-intercept is this value here where the line crosses the y-axis. The slope we have to get off the equation here. So I've got the equation. I'm going to go ahead and enlarge that. Whoops, let's try it again. I want you to be able to see this a bit better. So I'm going to enlarge the font here, and we'll make it 16. There we go, that's better. And this is a line in the form of y equals mx plus b. And when you've got a line like this, that's the y, that's the x. This here is going to be the slope. So that's the value I want you to put into your data sheet. When you do it, you have a slope here. The unit on the slope says slope with unit. The unit on a slope, because it's change in y over change in x is going to be milliliters per degree Celsius. I'll go ahead and write that in for you. So the unit is going to look like this: milliliter per degrees C. And whatever value that you come up with here that goes in front of that x, that's what goes in here in the slope. The y-intercept is actually this value right here, and you can see that would be about right. See, it's between 200 and 250, but that's it there, 210.91, and whatever you get, that's what you'll put. That's what you'll put into the y-intercept. The unit on the y-intercept is going to be the same as the unit on the y-axis, which is mils. So the unit on this is going to be milliliters. So you'll have, whoops. So you'll have whatever number goes in here, and then the unit will be milliliters. Now, to get the actual temperature of absolute zero, you'll take this value, which is the y-intercept, divide it by this value, which is the slope, and that will give you a value in degrees Celsius. It also says a minus here out the front though, so that will be a positive value that you'll get for here. You take the negative of that, and that will give you your T0, or the value at absolute zero. To calculate your percent error, these little lines here on each side mean take the absolute value, and all that means is when you take your T0 value, which is the value you calculate, you subtract 273.15. If the value happens to be negative, then you just make it positive. If the value happens to be positive, then you just leave it as positive. So that's just for this part here, T0 minus 273.15. So you take that value, divide it by 273.15, and then multiply it by 100%. So again, take T0 minus 273.15, ignore the negative if it happens to be negative, take that value, divide that by 273.15, and then take the whole thing and multiply it by 100%, and that'll give you your percent error. That tells you how close you were to the actual value of absolute zero, which is negative 273.15. You've gone ahead and gotten that graph. I'd like you to submit it to me, and the way you can do that is by taking a screenshot. Now, it depends upon what kind of computer you're using, but if you're using a Mac, you can use Command-Shift-4, and that will enable you to take a screenshot of a given area. Or if you're using a PC, you can use print screen, and you can copy and paste that image into Paint. And I'd definitely recommend for either user of a Mac or a PC that you Google that, how to take a screenshot, and that picture file, that's what you'll end up submitting to me.